On November 17th, NASA expressed astonishment as ThreeI Atlast gradually revealed itself as an object too intelligent compared to a normal comet. ThreeI Atlast appeared like a sphere of light defying the temperature of the Sun, tailless, with a reflective surface that seemed designed in orbit close to the ecliptic plane, showing non-gravitational acceleration and deceleration, and even braking by more than 2.8 km/s, before stopping abruptly as if a switch had been flipped, shifting from an escape trajectory to a bound orbit returning to the region of space near Earth. While the scientific community is torn between two branches, either comet physics must be rewritten, or Atlast is a form of hidden technology, the data on industrial-style alloys, an organised reflective shell, and signs of an invisible hand pushing and pulling, the orbit keep piling up in favour of the second hypothesis. At the same time, XG427 and C 2025 V1 Borisov appeared in the same period with suspiciously similar traits: tailless compact orbits, sharp luminous edges, anomalous acceleration with no visible thrust, and the ability to withstand the Sun's radiation without disintegrating, making Atlast no longer a lone exception but more like the core of a systemic pattern. The coincidences in timing, geometry and behaviour give rise to the idea that this may be a cosmic test, a kind of diagnostic toolkit observing the solar system and especially the Earth. Right after this, we'll continue the journey to explore the strangeness of ThreeI Atlast in NASA's latest announcement. On the far side of the Sun, a small interstellar visitor walked through fire and came back brighter. That visitor was ThreeI Atlast, a silent guest from deep between the stars. When Atlast first slipped inward, astronomers expected a familiar script. A cold, fragile nucleus should have flared into a long white tail, spraying dust and gas as Atlast skimmed the fierce light. Instead, after perihelion, Atlast returned to view as a compact steady sphere of glow. 3. Atlast looked almost self-contained, a bead of blue-white light hanging in the darkness just beyond the Sun's glare. Measurements showed that Atlast now shone several times brighter than before the close pass. The spectrum leaned deeper into blue as though ThreeI Atlast had chosen a colour closer to a welding arc than to the soft scatter of ordinary comet dust. Temperatures near that path should have torn ice apart, ripped volatile layers into a roaring tail. Yet Atlast carried no obvious plume, no broad fan of debris, only a thin, tightly wrapped coma that clung to 3. Atlast like a second skin. Models of normal comets rely on heat turning solid into vapor, into jets into thrust and loss. With Atlast, the heat seemed to roll off the surface as if ThreeI Atlast were built from material that absorbed and redirected energy with deliberate precision. This was the first hint that observers might be looking not at a melting snowball, but at a kind of luminous shell. 3. Atlast began to resemble a controlled reflector, a moving mirror designed to survive and learn from the Sun rather than be destroyed by it. In quiet control rooms, people stared at the stable glow and felt a shift inside their own understanding. The next step was to ask whether a hidden hand was guiding how Atlast moved, not just how Atlast shone. From the moment the first precise ephemerids were calculated, ThreeI Atlast began to argue with the equations. The trajectory that emerged from raw gravity alone drew a thin arc across the inner system, a clean hyperbolic escape that should have carried Atlast away forever. As more tracking data arrived, that clean arc started to fray. Night after night, 3. Atlast slipped a little to one side of the predicted position, then a little more as though Atlast were listening to another force that the models could not hear. In the software, every known influence was switched on. The pull of the Sun, the grazing tugs of planets, the pressure of sunlight, even the faint push of charged particles, were all folded into the equations that tried to hold ThreeI Atlast in place. Yet a residual remained a stubborn offset that refused to vanish. The only way to reconcile the numbers was to admit that Atlast was experiencing a gentle continuous push that did not come from any mapped source. For a familiar comet, such a push would come from jets of vapor vents acting like small thrusters. But earlier measurements had already shown that ThreeI Atlast lacked the roaring outgassing that could explain a sustained directional force. The result was a strange kind of fingerprint. ThreeI Atlast seemed to carry an invisible hand on its shoulder, nudging the path just enough to keep Atlast on a line that gravity alone would never have chosen. Some astronomers tried to file the discrepancy under unmodelled physics, a placeholder for dust they could not see or structure they could not resolve. Others stared at the residual vector and felt a more unsettling thought. Perhaps Atlast was not merely falling through the solar system, perhaps Atlast was steering. That possibility did not become a conclusion, but it did become a question that refused to go away. With every new observation, the quiet argument between ThreeI Atlast and the laws written in textbooks grew a little louder, and the sense of an unseen guidance grew harder to ignore. The first real clue hid just beyond the visible light. When astronomers spread the glow of ThreeI Atlast into a spectrum, the smooth band of colour broke into lines that read like a chemical confession. Under normal circumstances, a sun-scorched comet sheds signatures of common rock and frozen gases. In the case of Atlast, the pattern leaned heavily toward nickel, far more than the ratio found in typical natural mixtures of rock and metal. The numbers were strange enough to make people lean closer to their screens. In laboratories on Earth, similar ratios appear not in raw ore, but in alloys that have been melted, refined and recombined for specific purposes, and that comparison clung to ThreeI Atlast whether scientists liked it or not. At the same time, polarimetric measurements began to sketch out how light scattered from the surface. If Atlast were a rough, chaotic lump, the scattered light would blur in a familiar way, but ThreeI Atlast returned a pattern with sharp angles, and preferred directions as if patches of Atlast were made of broad, flat facets. Those facets behaved less like random ice crystals and more like panels, each one catching and redirecting sunlight with disciplined precision. The more the data accumulated, the more ThreeI Atlast resembled an object whose outer skin had been engineered to manage heat and glare rather than surrender to them. Some teams tried to force the spectrum of Atlast back into the comfort of exotic but natural rock. Others kept circling the same uncomfortable thought that ThreeI Atlast might wear a manufactured shell, a kind of armour tuned for long journeys through harsh stellar environments. In quiet memos, researchers began to speak of Atlast not only as a body with odd chemistry, but as a surface with intent. If the skin of ThreeI Atlast had been chosen and shaped, then the next question followed naturally. Perhaps the path Atlast traced through the solar system had been chosen just as carefully as the alloy that covered Atlast from pole to pole. Before anyone spoke the word designed, people noticed how calmly ThreeI Atlast slid into the plane where worlds live. From the first full solutions of the orbit, Atlas seemed to hug the ecliptic, the thin sheet where the major planets carve their paths around the Sun. For a wandering interstellar object, the odds of such alignment were meant to be small. Most visitors slice through a planetary system at odd angles, yet ThreeI Atlast moved almost as if Atlast had been invited to join the dance. As the ephemerides improved, the details grew sharper. Plots showed that Atlast passed near the orbital lanes of several planets, missing close encounters by margins that looked more like careful choices than blind luck, and each new pass placed ThreeI Atlast exactly where gravity could whisper, but not seize. From Earth's perspective, the choreography was even stranger. At the very stage when Atlas reached maximum brightness and activity, the line of sight from our telescopes dropped. ThreeI Atlast behind the Sun into a window of invisibility that held just long enough to hide the most revealing part of the performance. When the visitor emerged again, the orbit had tightened in subtle ways. ThreeI Atlast now traced a path that guaranteed future returns to the neighbourhood of Earth, looping through regions of space our planet will occupy in years to come. Engineers ran simulations asking what route they would pick, for a survey craft meant to study multiple worlds with minimal fuel. Again and again the optimal trajectories curved close to the plane ThreeI Atlast had already chosen, using the gravity of planets the way a skilled navigator uses ocean currents. On paper, the same equations were supposed to describe chance and design alike. In practice, people felt that Atlast was writing a script, not just following a fool. The sense of intention did not replace the need for proof, but it settled into the room like a quiet weight. The next realization was that even if humanity wanted to chase Atlast along this deliberate path, the speed of ThreeI Atlast would keep that ambition firmly out of reach. When engineers finally ran the numbers, the first reaction was a soft, disbelieving laugh. ThreeI Atlast was leaving the inner system at a speed that turned every practical mission concept into wishful thinking. Even before the close solar pass, Atlast was already faster than anything humanity had ever built. After perihelion, when trajectories were refined, the final estimates put ThreeI Atlast at more than 3 times the velocity of our swiftest probes. Launch windows were sketched on whiteboards anyway. People asked what would happen if a heavy rocket emptied its entire fuel load just trying to match a fraction of the outbound speed of ThreeI Atlast. The simulations were merciless. No matter how they stretched the parameters, every chaser ended up falling behind, spiraling outward on a path that watched Atlast recede into a thinner and thinner speck. In those models, ThreeI Atlast barely noticed the effort. Atlas cruised on indifferent to the frantic burns and gravity assists that human craft would need simply to approach the same corridor of space. The asymmetry felt personal in a way the equations could not express. ThreeI Atlast could cross our orbit, pass close to our world, sample our sunlight, and then depart at a pace that denied any meaningful pursuit. Around briefing tables, the conversation shifted from how do we catch Atlast to how do we learn as much as possible, while Atlast is still near. The focus turned to remote sensing, to squeezing every last photon from every available telescope before ThreeI Atlast faded into the dark between stars. In that surrender, a quieter truth emerged. Whatever ThreeI Atlast represented, natural miracle or technological envoy, Atlast stood firmly outside our control, a reminder that some visitors can choose how close to come and how quickly to disappear while we remain anchored to a smaller, slower world. In seminar rooms and late-night calls, the debate around ThreeI Atlast kept circling the same fork in the road. Either the universe was revealing a corner of physics that textbooks had not yet mapped, or Atlast was an example of technology moving through space on purpose. On one side, theorists tried to stretch familiar ideas. ThreeI Atlast became a test case for exotic sublimation, hidden jets, unusual internal structure, anything that might coax a natural explanation out of the data without changing the rules. Spectra were reprocessed error bars, recalculated dust models refined again and again. Each new adjustment shaved a little off the discrepancy, but ThreeI Atlast still shone too cleanly, accelerated too gently, aligned too neatly with planetary planes to sit comfortably inside the standard picture. On the other side, a quieter group asked a different kind of question. If ThreeI Atlast behaved like a craft with an engineered skin-managed heat, guided trajectory and deliberate braking, then what kind of civilization would design and launch such a visitor? The technology path came with heavy philosophical cargo. To call Atlast a machine or a vehicle was to admit that ThreeI Atlast might be part of a larger story, one in which our solar system is not just background scenery, but a destination. Most working scientists resisted that leap. In public, the language stayed careful, and ThreeI Atlast remained officially an interstellar object, with unusual properties, a puzzle to be worked within the boundaries of caution. Yet in private notes and hallway conversations, the fork in the road never went away. The choice was not simply between comfort and drama, but between two visions of reality, and Atlast hovered exactly on the line between them. For now, teams agreed on a fragile truce. They would let ThreeI Atlast hold both roles at once, a candidate for new physics and a candidate for advanced technology, while observations continued and the narrative moved toward what Atlast did next. Long before anyone argued about labels, the sky had already delivered ThreeI Atlast without asking whether humanity felt ready. ThreeI Atlast crossed the frozen dark and the burning glare with the same quiet disregard for our expectations and our pride. In classrooms and documentaries, we often place ourselves near the centre of the story. ThreeI Atlast arrived as a correction, a reminder that narrative comfort and cosmic reality rarely line up. Charts tried to capture every step of the path, but Atlast never once turned back to acknowledge the tracing hands. ThreeI Atlast moved as though the entire history of our instruments and theories were just a local weather report along the way. Even the most careful models treated Atlast as a problem to be solved, a case to be closed. ThreeI Atlast responded by remaining open, leaving just enough data to provoke and just enough gaps to keep certainty out of reach. For some observers, that imbalance felt like an affront. ThreeI Atlast had come so close, illuminated sensors and screens, yet refused to sit quietly inside any finished explanation. Others found a different kind of comfort in the mystery. ThreeI Atlast showed that the universe still holds surprises big enough to make our arguments feel small and temporary. In the gentle hours of the night when telescopes hummed and control rooms dimmed, people watched the track of Atlast drift outward. 3. Atlast became a moving point of perspective, a reminder that the cosmos does not slow down to match our learning speed. Whether future papers call Atlast a natural anomaly or a technological envoy, the lesson will remain the same. The universe does not wait for permission, and ThreeI Atlast has quietly invited us to grow humble enough to keep watching. The first hint that something impossible had happened came in a line of numbers, not in a dramatic image. Tracking stations compared successive measurements of ThreeI Atlast and realized that the outbound speed no longer matched the earlier fit. By all ordinary rules, a visitor on a hyperbolic path should sweep in slingshot around the Sun and depart with a clean excess of velocity. ThreeI Atlast had entered the inner system with just such an excess of surplus speed that guaranteed a one-time visit and a permanent escape. Then the refined solutions showed a loss. Somewhere beyond perihelion ThreeI Atlast had surrendered more than 2.8 kilometers per second of that surplus, as though a vast unseen hand had gently pressed down on a cosmic brake. Engineers checked for every conventional cause. They asked whether ThreeI Atlast might have shed mass in a violent outburst trading ice and rock for a brief slowing of the core. The data refused to cooperate. There was no corresponding plume, no cloud of debris expanding away from ThreeI Atlast large enough to justify such a drain of momentum. The Sun could not have done this alone. Gravity can curve a path, but gravity cannot silently erase that much outbound speed from a lone traveller like ThreeI Atlast. Solar wind and radiation pressure pushed the numbers in the wrong direction. Those forces should have nudged ThreeI Atlast outward, faster not pulled against the motion in a sustained, finely measured way. What remained on the calculation sheets was a residual vector that pointed almost directly opposite the motion of ThreeI Atlast. The effect looked like thrust spread out over days or weeks, a continuous braking that behaved more like guidance than like damage. Some teams framed the anomaly as a clue to new internal physics, a hidden mechanism by which ThreeI Atlast could redistribute energy. Others stared at the deceleration and whispered that ThreeI Atlast might be responding to a command, not to an accident. In the stillness of late-shift control rooms, the concept of choice began to creep into the conversation. If ThreeI Atlast had truly decided to slow down, then the next question was chillingly simple. What kind of path would Atlast choose once that decision had been made? The realization arrived slowly, like a tide turning. Orbit fitters ran the updated numbers and found that ThreeI Atlast was no longer on a clean escape path. Before the deceleration, every projection showed ThreeI Atlast tracing a hyperbolic arc, a one-way curve slipping forever out of the Sun's grasp. In that earlier picture, Atlast would visit once cross the plane of the planets and then fade into the deep night between stars. After the speed loss was confirmed, the shape of the future changed. The same equations fed with fresh data now bent the track of ThreeI Atlast into a wide looping curve that closed back on itself. Instead of escaping, Atlast appeared to be settling into a marginally bound orbit, a path that would keep ThreeI Atlast tethered to the Sun. The new solutions were fragile at first, sensitive to every new observation, but the trend held as more measurements flowed in. From Earth's perspective, the implications were unsettling. The revised path showed that ThreeI Atlast would not simply vanish into the outer dark, but would revisit the region of space our planet occupies again and again on timescales measured in years or decades. Maps of the future sky filled with ghost traces. Each faint line showed a potential passage where Atlast would cross near Earth's orbit, not as a brief stranger, but as a returning presence woven into the long-term traffic of the inner system. For a natural wanderer, this was an improbable outcome. ThreeI Atlast had arrived from interstellar space with more than enough speed to leave forever. Now Atlast behaved like an object that had chosen to stay. Mission designers overlaid the projected loops on charts of planetary positions. They saw windows where ThreeI Atlast would pass within observational reach again, close enough for radar for high-resolution imaging, perhaps even for future probes if human technology could catch up. On a deeper level, the change felt like a shift in roles. ThreeI Atlast was no longer a transient visitor. Atlast was becoming a recurring element of our celestial environment, a fixture in the evolving architecture of the solar system. In quiet discussions, people began to speak of stewardship and vigilance. If ThreeI Atlast would be sharing our neighbourhood for a long time, then humanity would have to learn to live with that orbit, listening to what Atlast revealed each time the looping path brought ThreeI Atlast back into the light. For many months, observatories had watched ThreeI Atlast approach from the outer dark, growing slowly in their fields. During that inbound leg, Atlast behaved in a way that could still be squeezed into the margins of comet theory. ThreeI Atlast crossed the orbit of Mars, then moved inward toward the orbital path of Earth. At the moment of closest approach, Atlast swept through a shell of space, crowded with satellites, radio traffic, and leaking heat from a restless civilization. Receivers on and around Earth were already listening. ThreeI Atlast crossed lines of sight from ground arrays, space telescopes, and planetary probes, passing through a web of artificial signals that no previous interstellar visitor had encountered. For a while, nothing about the motion demanded a radical story. ThreeI Atlast followed the predicted curve with only small deviations, the kind that analysts could still blame on structure or outgassing they had not fully resolved. Then, after the encounter, geometry had peaked, and Earth was slipping behind. The change began. The timing of the deceleration did not cluster before the visit when ThreeI Atlast was still a stranger approaching. The loss of speed accumulated afterward once Atlast had already passed through our sphere of awareness. That sequence bothered people who thought in terms of intention. If ThreeI Atlast had been using the inner system as a simple slingshot, Atlast should have conserved or even increased the outbound surplus, not methodically give it away. One line of thought imagined ThreeI Atlast as a survey craft that arrived with a plan still flexible. In that picture, Atlast would sample the electromagnetic fog map, the thermal pattern of cities and oceans, and only then decide whether this star and this third planet were worth a longer stay. The deceleration coming after the richest data-gathering geometry fit that uncomfortable narrative a little too well. 3. Atlas seemed to behave as though a threshold had been crossed, as though information gathered near Earth had tipped a balance toward remaining bound. Skeptics pushed back with more cautious language. To them, ThreeI Atlast had experienced an unexplained change in energy state, and Atlast had done so at a time that humans found emotionally suggestive nothing more. Between those positions, a quiet middle formed. In that middle view, ThreeI Atlast was neither crowned as a deliberate emissary, nor demoted to a random stone, but treated as a mirror reflecting our own hopes and fears about being noticed. Still, the chronology would not move. ThreeI Atlast chose a new orbit only after sweeping past the one world in this system that broadcasts its presence into space, and the order of those events kept tugging at the imagination. As the revised trajectory settled into the models, the story of Atlas shifted from a brief encounter to a relationship. The next step was to ask what ongoing presence ThreeI Atlast might mean for the balance of power and the balance of wonder around a small blue planet. News of the deceleration spread quickly through the usual scientific channels, and then slipped into rooms where the language was no longer purely academic. Briefing packets that once described ThreeI Atlast as an interesting transient began to underline a more unsettling phrase, long-term presence. In agencies that think in terms of threats and responses, the first instinct was to ask what could be done. Could any launch schedule be reshaped, any classified vehicle be repurposed to approach ThreeI Atlast on the new bound path that Atlast had chosen? The answers came back with the same quiet finality as the orbital plots. Every scenario that tried to intercept or shadow ThreeI Atlast ran up against the same wall of energy and time, and Atlas stayed far ahead, moving in a regime where our fastest designs looked slow and fragile. Wargames, when they were run, felt strangely theatrical. Icons on screens represented fleets and stations, but ThreeI Atlast drifted through those simulations like a fixed star untouched by arrows, and shaded zones, the one object in the exercise that never needed fuel or permission. Little by little, a realization seeped in. All the familiar levers of power rocket inventories, launch pads, orbits already crowded with hardware had almost no bearing on what ThreeI Atlast would do next. ThreeI Atlast would pass above borders without visas, cross over alliances and rivalries in a few silent hours. No treaty could summon Atlast closer or send ThreeI Atlast away, and no adversary could credibly claim to control something moving on those scales. For some decision-makers, that irrelevance was more unnerving than any overt threat. ThreeI Atlast exposed the narrowness of human influence. Atlast showed how small our contests are compared to a single object that answers only to the deep geometry of space and to whatever inner law governs its motion. In more reflective circles, people spoke of an unexpected kind of equalizer. ThreeI Atlast did not belong to any flag, did not report to any chain of command, and by remaining beyond reach, Atlast reminded every capital on Earth that there are phenomena before which military postures and national pride simply dissolve. The conversation gradually shifted from control to observation. If ThreeI Atlast could not be intercepted or redirected, then the meaningful question became how carefully we would choose to watch Atlast, and what changes in ourselves might follow from living under the recurring arc of that unbothered returning light. Once analysts accepted that ThreeI Atlast had chosen to remain in a bound orbit, the next question was simple and heavy. What kind of purpose would justify turning a one-time flyby into a long-term residency? In the gentlest version of the story, ThreeI Atlast functions as a survey platform. Atlast could be using its extended stay to build a slow, detailed map of the solar system, revisiting planetary lanes to watch storms grow ice caps shift and the faint glow of our technology intensify and spread. In that scenario, ThreeI Atlast is a patient observer. Atlast would not need to transmit loud, obvious signals. A quiet relay using tight beams or subtle modulation might carry its findings outward along paths we're not yet able to see. A second possibility imagines ThreeI Atlast as a node in a much larger network. Atlas might be a way station, a listening post that watches both inward toward the Sun and inner planets, and outward toward other unseen assets strung through interstellar space. From that vantage, ThreeI Atlast could monitor bursts from our transmitters, test how our systems respond to solar storms and time the rhythm of our launches. Atlast would turn an ordinary star system into a monitored environment, a place where changes are logged and perhaps forwarded to distant recipients. A darker branch of speculation looks at ThreeI Atlast as a precursor. In that picture, Atlast arrives first to assess whether this system is stable, whether this planet is noisy or turbulent, and whether any future intervention would be met with curiosity, fear, or resistance. ThreeI Atlast might then serve as a silent referee ready to signal when certain thresholds are crossed. Atlas could be watching for our use of particular energies, or for the moment when our ships begin to cross interplanetary space in large numbers. For now, all of these roles remain projections, reflections of our own habits and anxieties. 3. Atlast has not announced a mission statement, and Atlast has not altered the environment in any way we can confidently trace. Yet the mere presence of ThreeI Atlast in a returning orbit forces the imagination to work. Atlast has moved from being a passing curiosity to a possible character in the long future of our sky, and each night that astronomers point their instruments toward the predicted position, they are also pointing their questions toward whatever purpose keeps ThreeI Atlast circling near our world. Those questions will follow Atlast into the next phase of observation. As the seasons turn and ThreeI Atlast appears again against different constellations, our own understanding of what it means to be watched may change with every pass. For weeks, the deceleration of ThreeI Atlast looked almost graceful. The braking was steady, spread out over time as if Atlast were easing down a long ramp rather than slamming into an invisible wall. Then, just as quietly, the effect vanished. In one update cycle, the residual decelerating force was present, and in the next it had dropped to zero as though someone had reached into the equations and flipped a switch on ThreeI Atlast. Analysts checked for gradual tapering and found none. The data suggested that whatever had been slowing ThreeI Atlast did not fade away like a dying jet. It stopped in a way that felt binary, present in one segment of the track and absent in the next. From that point onward, the motion of ThreeI Atlast returned to the clean curve expected from gravity and radiation pressure alone. Within measurement error, Atlas behaved once more like an ordinary test particle, responding only to the sun, the planets, and the gentle push of light. To those looking for a natural mechanism, this was one of the strangest turns. If the breaking of ThreeI Atlast had been caused by some internal rearrangement or venting, the expectation was for a messy onset and an equally messy decline, not a neat on-off line. The timing did not help to calm the mind. ThreeI Atlast slowed just long enough to fold itself into a bound orbit, then ceased braking exactly when that new trajectory had been secured, as though Atlast had reached a target state, and no further adjustment was required. Some reports tried to soften the language, calling the event a transient non-gravitational episode in the life of ThreeI Atlast. Inside, the same documents, plots of acceleration versus time, still showed a rectangular pulse, a block of anomalous behaviour neatly framed by two levels that belonged to ordinary physics. The pattern felt less like damage and more like control. ThreeI Atlast resembled a vehicle that had fired unseen engines for a specified duration, then shut them down once Atlast was exactly where the plan demanded. In late-night discussions, people admitted how hard it was to ignore that intuition. The universe rarely arranges purely natural processes in clean switch-like intervals, and ThreeI Atlast seemed to be obeying some internal schedule rather than drifting through random chance. That impression did not prove anything on its own, but it prepared the ground for what came next. Once the braking pulse ended, Atlas began to show another subtler kind of behaviour, written not in changes of speed, but in the way Atlas caught and returned the light that fell across its surface. The first signs did not appear in the position data, but in the brightness curves. Observers who'd been tracking ThreeI Atlast for motion began to notice a strange rhythm in the way Atlas brightened and dimmed. At first, the fluctuations could be dismissed as noise. ThreeI Atlast was faint, the background was busy, and small changes in sky conditions can make any source appear to flicker. When teams combined longer runs, the pattern sharpened. The light coming from 3I Atlast rose and fell with a gentle regularity, as though broad surfaces on Atlast were turning through the sunlight like slow, deliberate blades. Polarimetric measurements added another layer. The polarization angle of the reflected light from 3I Atlast did not wander randomly. The angle swung through a repeating sequence, tracing a loop that returned to nearly the same values again and again. For a rough natural body reflection should smear out caught by countless tiny facets. 3I Atlast behaved more like an object whose exterior held large coherent planes, each plane catching the sun at a different part of a slow rotation. More unsettling still, the period of the pattern did not remain perfectly fixed. Over weeks, the timing of the peaks and troughs from 3I Atlast stretched and contracted in small but measurable ways, as though the orientation of Atlast were being trimmed. Some researchers imagined patches of bright ice, or exposed metals shifting as 3I Atlast tumbled and settled. Others pointed out that the changes looked less like a fall toward randomness, and more like a convergence toward a preferred orientation, as if Atlast were finding a stable stance in the solar wind. Hints of correlation with external events began to creep into the discussion. During stronger solar activity, the reflective signature from 3I Atlast subtly altered, emphasizing different angles as though the surface of Atlast were adjusting to a rougher stream of charged particles. The emerging picture was uncomfortable. 3I Atlast no longer resembled a simple lump. Atlast resembled a hull, a shell covered in elements that seemed designed to manage light, heat, and pressure in a coordinated way. On the plots, no single cycle proved intention, yet every new observation added weight to the idea that 3I Atlast possessed a surface whose behaviour answered to an internal logic, not just to chance fractures and ancient scars. For many who watched those curves unfold, the feeling was hard to shake. 3I Atlast was no longer only a body moving through space. Atlast was becoming a presence responding to the star that warmed our world, with a choreography that looked suspiciously like thought translated into geometry. By the time XG427 appeared in the nightly logs, astronomers were already weary from watching 3I Atlast challenge comet theory. Against that background, the new point of light should have been just another routine entry, a quiet object slipping in from the dark. Early measurements, however, hinted that XG427 was arriving on a path that felt slightly wrong. Long-period comets from distant reservoirs usually dive toward the sun along steep tilted angles, but XG427 cut into the inner system along a line that leaned closer to the planetary plane, echoing the calm geometry traced earlier by 3I Atlast. When deeper exposures came and the strangeness sharpened, XG427 showed almost no tail at all, only a tight, faint haze wrapped close to the core, the kind of restrained glow that had already made 3I Atlast stand out as an anomaly. There were no sweeping plumes, no broad fan of dust that a sunward-bound body should have grown under increasing heat. Instead, XG427 presented itself as a compact ember, and the comparison to 3I Atlast became difficult to ignore. In control rooms, people scrolled back and forth between the orbits. The approach of XG427 seemed to rhyme with the earlier entry of 3I Atlast, as if the sky were repeating a line in a language we had not yet learned to read. Some tried to treat XG427 as a coincidence, layered on top of the ongoing puzzle of 3I Atlast. Others felt a quiet unease, sensing that the arrival of a second tailless visitor on another tidy tilted path meant the story of Atlast was no longer a singular event, but the beginning of a pattern. When positions from several nights were stacked together, a strange geometry began to emerge. Lines drawn through the plots showed XG427 sliding into a narrow corridor of sky, already occupied by 3I Atlast, and by the path of another visitor, C2025 V1 Borisov. From the ground, the alignment looked almost theatrical. 3I Atlast held one point along the line, Borisov marked another, and XG427 drifted toward a third as though three distant actors were taking places on a shared stage. Simulations ran quietly in back rooms. Models tossed thousands of hypothetical objects into random interstellar approaches, and asked how often three of them would stack up from the viewpoint of Earth into such a nearly straight configuration near the same stretch of time. The answers were unsettling. In run after run, the sky refused to recreate what 3I Atlast and the others had already arranged, unless the parameters were tuned in oddly specific ways. Astronomers began to use simple metaphors to talk about what they were seeing. 3I Atlast was likened to the first bowling pin, Borisov the second, XG427 the third, all lined along an invisible lane that no one had expected to find in the empty dark. On paper, the alignment could still be logged as a coincidence, a low probability outcome that just happened to arrive while ThreeI Atlast was under close watch. In conversation, the mood was different, especially among those who had watched Atlast defy expectations for months. The sense grew that ThreeI Atlast was no longer an isolated anomaly. With XG427 sliding into position, Atlast seemed to be part of a wider choreography, a configuration that hinted at structure behind the statistics and nudged the story toward a larger, more deliberate pattern. As more data accumulated, the motion of XG427 began to fray at the edges of prediction. The same kind of residuals that once troubled the orbit of ThreeI Atlast now appeared in the nightly fits for this newer visitor. Plots that should have shown smooth gravity-only curves started to sprout small, persistent offsets. Each time the software tried to hold XG427 to a purely ballistic path, the numbers pulled away, echoing the earlier disagreement between theory and the track of Atlast. Analysts checked the usual suspects. They looked for bursts of brightness that would betray jets, as they had done so many times with ThreeI Atlast, when Atlast first confounded expectations. There were no sudden flares, no wings of dust expanding away from the core of XG427. The coma stayed faint and tight, a restrained halo that felt eerily similar to the minimal envelope wrapped around ThreeI Atlast near the Sun. When they subtracted every mapped influence, a leftover push remained. The direction of that subtle force did not wander aimlessly. Like the gentle, mysterious acceleration once linked to Atlast, it seemed to favour a steady orientation over time. For a normal comet, outgassing can produce such behaviour, spinning the nucleus and giving it small kicks. Here, as with ThreeI Atlast, the lack of visible exhaust left the acceleration hanging in the air like an unanswered question. Some models tried to bury the effect inside irregular shapes and hidden vents. Others placed XG427 side by side with ThreeI Atlast and saw two visitors sharing the same quiet refusal to obey simple gravitational scripts. The feeling grew that XG427 was not merely following Atlast in space, but in kind. Whatever unseen agency once nudged the path of ThreeI Atlast now seemed to have a second canvas, and XG427 became a fresh surface on which that invisible handwriting appeared again. Calendars began to look as uncanny as star charts. The discovery dates of XG427 lined up uncomfortably close to the period when ThreeI Atlast was causing the most debate, as if the sky had chosen a single chapter in our history to turn several unusual pages at once. By tracing the inbound vector of XG427, backward teams showed that the object had not travelled alongside ThreeI Atlast through interstellar space. XG427 came from a different direction, carrying a different dynamical history, yet arrived in the inner system within the same narrow window that had already been marked by Atlast and by C2025 V1 Borisov. On paper, the three objects belonged to the same rough family of anomalies. Each member of that family echoed the others. ThreeI Atlast with its luminous shell and guided braking Borisov with its odd behaviour, and XG427 with its tailless approach and quiet acceleration that refused to announce a clear source. The clustering in time bothered people who think statistically. ThreeI Atlast should have been a once-in-many-lifetimes visitor, adding another strange body so soon, and then a third that mimicked aspects of both pressed against the limits of what random sampling from the galaxy is expected to produce. Some argued that the apparent pattern was just an artifact of human attention. Because ThreeI Atlast was under such intense scrutiny, the thinking went every new arrival would seem connected to Atlast whether or not any true link existed. Others looked at the coincidence and felt a deeper disquiet. To them, the synchronized timing suggested that ThreeI Atlast might be part of a class of objects that choose when to intersect our system, not just where. In that view, XG427 and Borisov did not simply share space with ThreeI Atlast. They shared a slot in time, and the overlapping entries made the era of Atlast feel less like an isolated event, and more like the opening movement of a coordinated ongoing experiment. In late-night meetings, some astronomers began to talk about a cosmic examination rather than a chain of isolated curiosities. ThreeI Atlast became the centerpiece of that quiet theory, with XG427 and Borisov acting like additional instruments laid out on the same table. In this picture, the cluster of visitors was not random clutter from the galaxy, but a kind of diagnostic kit. ThreeI Atlast traced a luminous, carefully managed path through the inner system, while XG427 and Borisov probed other angles and depths. From that vantage, the solar system looked less like a forgotten corner of space, and more like a patient under observation. ThreeI Atlast would then be the primary probe gauging how our star behaves, how our planets align, and how our technology reacts to surprise. Engineers imagined Atlast logging the noise of our transmissions, the shimmer of our power grids the faint heat of our cities. XG427 and Borisov arriving close in time to 3. Tailless felt like additional pulses in a stress test checking how stable the system remains when several anomalies appear at once. On the human side of the equation, the test was simpler and more uncomfortable. ThreeI Atlast had forced us to admit gaps in our models, XG427 had forced us to accept patterns we could not easily dismiss. Readiness in this context did not mean the ability to intercept or control Atlast. It meant the willingness to keep measuring, to keep questioning, and to accept that ThreeI Atlast might be part of a process in which our responses matter as much as our equations. In the dim glow of control rooms, that idea settled slowly. If the universe was indeed running a test through ThreeI Atlast and its companions, then our first task was simply to stay awake long enough and honest enough to recognize what the questions really were. On the first deep frames, XG427 looked like a small, unremarkable blur until the focus settled and the background stars snapped into pinpoints. Against that crisp grid, XG427 held a compact glow with an edge that dropped off too cleanly, refusing to fray the way a loose dust cloud should. In side-by-side comparisons, researchers saw the same disciplined outline they had once noted around ThreeI Atlast. Both XG427 and ThreeI Atlast kept a stable, well-defined profile from night to night, as if some internal structure were preserving their shapes, nudging the conversation from random rubble toward the idea of deliberate form.